Hi everybody, I'm Sandeep Gupta, and let's start with chapter number 2 of OOPM. Throughout the entire discussion, please follow this mouse pointer. So, the name of chapter number 2 is Fundamentals of Java, Java Operators, and Control Statements. The first part being Fundamentals of Java. So, please copy all the headings in your notebook and write refer PN. Pause the video and do that. Write refer PN also. Okay. Now, I assume you have copied all this. So let's start with the fundamental concepts of Java. The first fundamental concept of Java is called character set. Now, what is the meaning of character set? Character set means set of all characters allowed in the language. So you take example of any language, whether it is English, Hindi, whether it is C, Java. Every language has certain characters which are allowed in the language and certain which are not allowed in the language. If you take example of character k, kh, g, g, these characters are allowed in Hindi but not in English. So I will say k, kh, g, g is in the character set of Hindi but not English. So let's study the character set of Java. But first of all, let's talk about C programming language. The character set of C programming language is called Ascii Character Set. By the way, ASCII stands for American Standard Code for Information Interchange. And ASCII character set contains characters A to Z in uppercase, A to Z in lowercase, digits 0 to 9, and many other symbols like plus, minus, hash, @ and so on. Now, ASCII character set ranges from 0 to 127, which means that there are 128 characters in ASCII character set. If you talk about Java, Java uses something called Unicode Character Set, where the word uni stands for universal. So it is universal code character set. The range of this Unicode character set is from 0 to 65535, which means that the Unicode contains approximately 65,000 characters, approximately. Now, the moment I say this, you should have one question in your mind, and the question should be that why does Java need 65,000 characters? So the answer lies in two words, and those two words are internet programming. Remember, Java is the language of the internet, and internet is spread all over the universe, I mean all over the world. So what happens is Java contains characters of not only English language, it also contains characters of all the prominent languages from all over the world. So in Java, you can use characters of Hindi, Mandarin, French, Arabic, Japanese, and so on. And if you consider all the languages from all over the world, then the total is approximately 65,000. So that is why the range of Unicode is so large. But we don't need to worry. We don't need to worry about all these 65,000 characters for a very simple reason that ASCII is a subset of Unicode. The first 128 characters of Unicode is actually the ASCII character set. So we will be using ASCII. Okay. Now let's move on to the next fundamental of Java, and that is token. Now, how do you define a token? So I will say a token is the smallest individual unit in the program. I'm sure many of you did not understand what I said, so let me explain it to you in another way. See, when you do a program, in that program you will use a keyword, you will use an identifier, a constant, a operator, a separator, and so on. So a token is either a keyword or an identifier or a constant or an operator or a separator. If you still didn't understand what I mean, let's have a look at this example. Now, in this example, double is a keyword. Area is an identifier. This equal to symbol is an operator. 9.8 is a constant and semicolon is one of the separators. So all these things are collectively called tokens. Okay. So a token is basically a general name for all these things. By the way, one more small simple thing. I hope you remember a method, a function of C language is called method in Java. So similarly, a constant of C language is called literal in Java. So here onwards, whenever we say constant or literal, it's one and the same. Okay, now let's turn our attention to separator because this word is not used so often. So let's understand what is a separator. Very simple. A separator is either a parenthesis or braces or brackets or semicolon or comma or it is a period. By the way, this dot is sometimes also called dot operator or period operator. We will use this dot heavily from chapter number 4 onwards. In fact, in other subjects also where you use structures, you use dot very heavily. One more thing is, here onwards, we will never call this as round bracket or curly bracket or square bracket. Here onwards, this is parenthesis, this is braces, and this is brackets. And all these things are collectively called separators. Okay? Alright, now let's move on to the next fundamental concept of Java. So we start with a very important topic called data types. Now, can you think of one very simple example of data type which you already know? I'm sure you must have thought of int, which stands for integer. So that's right, int, float, double, char, all these are data types. So let's study data types in Java properly. Now if you talk about Java, all the data types in Java are broadly divided into two categories. The first category is called primitive or built-in or simple data type. The second category is called non-primitive or user-defined data type. We'll talk about user-defined data type when we do chapter number 4. Right now, let's talk about primitive or built-in data types. So, these primitive data types are called built-in data types because they are built inside the compiler. You, the programmer, does not need to create the built-in data type. Now, these are the categories of the built-in data type. And what you see over here are the names of the categories. They are not the names of the actual data types. So, the categories are integer, floating point, character, and Boolean. Okay. Now, I will show you a table of all these data types. In the first column, you see the name of the category. In the second column, the name of the data type. In the next column, memory requirement, and in the last column, range. So, as far as integer category is concerned, you have 4 data types: byte, short, int, long. Now, of these 4 data types, can you tell me which data type is completely new for you? Yeah, that's right, it's byte. So, let's talk about this data type in little detail. Okay. Now, let's say I write a word something like this. I write something like byte. Space B semicolon. Now this statement is called declaration. Whenever the compiler comes across this statement, it will do the work of memory allocation. So the compiler will create a variable B of data type byte and will store it in memory. If B is of data type byte, it will occupy 1 byte of memory. Moreover, now B can store any value between -128 to +127, and that is the meaning of the range of byte. So you cannot use B to store 130, 250 and so on. Alright, I hope the data type byte is clear. So that way we have 3 more data types in integer category: short, int, long. These are their memory requirements and these are their ranges. You don't need to by heart the range. As far as floating point category is concerned, there are two data types, float and double. The memory requirement is 4 and 8 byte. Now let's see how to read this range. There's nothing difficult about it, but you should just know how to read it. So you will read it this way. The range of float on the negative scale is minus 1.4 into 10 raised to minus 45. Look at the mouse pointer. To minus 3.4 into 10 raised to plus 38. On the positive scale, it is plus 1.4 into 10 raised to minus 45 to plus 3.4 into 10 raised to plus 38. So that way you have the range of double also. Now as far as character is concerned, you have only one data type char. Okay, this is the memory requirement, this is the range. Now let's turn our attention to a very important data type called Boolean. Have a quick look at its memory requirement and range. See it carefully. You will realize that the memory requirement of Boolean is 1 bit, not 1 byte. Okay, that means it will take. By the way, I hope you remember that 1 byte is of 8 bits. So Boolean will not take 1 byte of memory. It will take only 1 bit of memory. And a Boolean data type can take only two values, true or false. Now let's understand this properly. There's something important to be understood over here. Please pay attention. Let's say I write a statement like this: Boolean space m semicolon. I hope by now you know that this statement is called declaration. If m is of data type Boolean, then m can be either equal to true or m can be either equal to false. So you can write m equal to true, m equal to false, that's it. Now there is one very important thing which I want you all to understand over here. See, what happens in C programming language is that we consider 1 as true and 0 as false. But please understand that the concept of 1 being true and 0 being false does not exist in Java. So if m is of data type Boolean, and if you write a statement m equal to 1 or m equal to 0, then the compiler will report an error. Okay, so Java is pretty straightforward. True is true, false is false. There is no 1 0 in Java. It exists in C language. Okay, alright. So basically this is the table of all the data types in Java. There are 4 integers, 2 floating point, 1 character, 1 Boolean. By the way, float and double are sometimes also called real numbers. I repeat, real numbers. A real number is a number which has a decimal point. Now let's talk a little more about this float data type. Please be attentive. See, here onwards, whenever I want to work on a real number, I will never use data type float. I will always use data type double. Now what is the reason of that? Why will I not use data type float? Why will I use data type double? Okay, so let me explain that to you. Let's say I write a statement like this: float m equal to 6.7 semicolon. So this statement is called declaration and initialization. Now what happens is, if I write this statement, the compiler will report an error. Because if I'm creating a float variable, then I should compulsorily include the alphabet f over here. I'm talking about this f which I wrote over here. So if you don't write this f over here, the compiler will report an error. So you will have to spend your time debugging your program. So in order to avoid all that problems, here onwards, whenever I want to work with a real number, I will not use data type float, I will use data type double. Okay, so this was a table of data types in C language. Now before this table, I had showed you one small simple diagram. This diagram is not there in your printed notes, so pause the video and quickly draw this diagram in your notebook. Okay, I hope you have already drawn the diagram. So let's move ahead from the topic of data type. Okay. Now let's talk about variables and constants. Come on. Now what are variables and constants? Look at this statement. Tell me over here who are variables. That's right, A and B. And who is the constant? That's right, 98. Now, a variable is something whose value can keep on varying, can keep on changing. Whereas a constant is something whose value will remain same, fixed, constant. And in Java, a constant is also known as a literal. Okay. Now, once you understand what is a variable, what is a constant, now let's talk about different types of constants. So, as far as constants are concerned, there are 5 categories of constants: integer constants, real constants, single character constants, string constants, and Boolean constants. When I show you example of these constants, you will find them very simple. So, have a look at this particular diagram. Any integer number, look at the mouse pointer, look at the pointer. Any integer number is called an integer constant. So something like 256 is an integer constant. 45,627 is an integer constant. Now what is a real constant? So any number having a decimal point is called a real constant. So these two are examples of real constants. What are single character constants? By the way, single character constants are sometimes also called character constants. A single character constant is a single character enclosed in apostrophe. By the way, apostrophe means a single quotation mark. So when you put B in single quote, it becomes a single character constant. When you put hash in single quote, it becomes a single character constant. You may also put any digit in single quote, that is a single character constant. So here I have put 9 in single quote, it is also a single character constant. So once again, a single character constant is any single character enclosed in single quote. Now let's go to string constants. Very simple, you just have to listen to me carefully. A string constant is a collection of 0 or 1 or multiple characters enclosed in double quotation marks. I repeat, it is a collection of 0 or 1 or multiple characters enclosed in double quotation marks. For example, look over here. This is the first example in which there are 0 characters in double quotes. So this is a string constant. 1 character in double quote, string constant. 3 characters in double quote, string constant. Now what are Boolean constants? The simplest. There are only 2 Boolean constants in Java, true and false. That's it. So these are the categories of constants. Again, do one thing. Pause this video, and in your printed notes you will find this diagram, you will find this chart, but you will not find these examples below the diagram. So pause the video and copy these examples quickly. Okay, I think we have already copied the examples, so let's move ahead. So now once you know constants, let's talk about final variables. Now have a look at this statement. This statement is called declaration and initialization. In this statement, I have created a variable pi. After writing this statement, after declaring pi, if I write this statement, what do you think? Is it valid or invalid? My answer is valid. See, the thing is, pi is a variable, and a variable is something whose value can be varied. So if I change the value of pi to 9.8, this is valid, no problem. But let's say instead of writing this statement, now I write this statement. Now if I write this statement, in this statement you see a new keyword called final. If you pay attention to final, you will realize what it says. It says that now 3.141593 is the final value of pi. In other words, pi is now called final variable. So after writing this statement, if I write this statement, the next one, pi equal to 9.8, what will happen? That's right, the compiler will report an error because pi is a final variable, its value cannot be changed. Okay, so now what we studied before these were fundamental concepts of Java. Now we start with the next topic, B operators. So do one thing, in your printed notes write B operators and below that write refer PN. Do that quickly, pause the video and do that quickly. Okay, now what I want is, again I want you all to pause the video and quickly go through your printed notes chapter number 2. What you do is quickly run your eyes over the entire chapter number 2 in your printed notes. So pause the video and do that quickly. Okay, I think you have already done that. So if you see your printed notes very carefully, chapter number 2, you will realize most of the things in chapter number 2 are similar to C programming language. Okay. So what I have decided is that I will not teach you the same thing which you have already studied in SPAC. What I will do is I will teach you only those things which are new in Java. Okay. So we are doing this to save time so that we can start our mini project as early as possible. So as far as operators is concerned, let me talk a little about this operator. By the way, if you remember, this is called Modulus Operator, which you have studied even in C programming language. But what I told you is that I will teach you those things which are completely new for you or which are slightly new for you. So what happens is, in C language, the modulus operator can work only with integers. But in Java, the modulus operator can work with real numbers also. Now let's see how it works with real numbers. So I'll give you one example, which is this. I'll say that 13.8 modulus 2.9 is equal to 2.2. Now you may have a question in your mind how I arrived at the answer 2.2. So there is one rule which you should understand first. See over here, 13.8 is the dividend, 2.9 is the divisor, and 2.2 is the remainder after division. I repeat, this is dividend, this is divisor, and this is the remainder. Now, there's only one rule which you should know over here, and that rule is that when you are using modulus operator in Java, modulus operator can work with real numbers, but the quotient must be an integer. I repeat, the quotient must be an integer. So I will show you two statements, this being the first one and this being the second one. If you look at the two statements, you should realize that in this example the quotient is 4. So if the quotient is 4, then 2.9 into 4 is 11.6 and 13.8 minus 11.6 is 2.2. So that gives us this answer. Okay. Now let's study a few more rules about modulus operator. But now I will not call this dividend and divisor. I will call this as the first operand and I'll call this as the second operand. Now one more rule about modulus operator is that if the first operand is lesser than the second operand, the answer is the first operand. So 2.9 modulus 13.8 is 2.9. Another rule about modulus operator is the sign of the result. When I say sign, I mean positive or negative. The sign of the result is same as the sign of the first operand, irrespective of the sign of the second operand. So look at these examples. First one, first operand negative, answer is negative. Second operand negative, answer is negative. Okay. So the sign of the result is always same as the sign of the first operand, irrespective of the sign of the second operand. Just in case you have minus 13.8, modulus minus 2.9, what do you think will be the result? it will be minus 2.2. Okay, so don't do cancellation of negative sign over here. Okay. Alright, now I'll give you a quick exercise. So what you should do is, in your notebook you should copy all these things, whatever you see over here, and after that you should find out the value of x modulus y. Okay, so pause the video, copy all this and find the value of x modulus y on your own. Come on, start. Okay, I think you have already done that. So x modulus y is 2.091 and the quotient over here is 5. Okay, you can copy this. Okay, so now let's move ahead. Now you have two operators in Java which are called short circuit operators. I repeat, they are called short circuit operators. Now what are these short circuit operators? I will explain you, and after that you will be writing a note about them in your own words. Okay, so in order to explain that to you, have a look over here. Yeah. Okay, now tell me, are you aware of these two operators? You are. This is called logical and this is called logical or. In Java, both of them are collectively called short circuit operators. Now why they are called that way, I'll explain you and you will write a note about it in your own words in your notebook. Okay, so let's say I write something like this: A greater than B and X lesser than Y. Okay, now there are two conditions over here, please be attentive: A greater than B and X greater than Y. In order to understand that why they are called short circuit operators, you should first know the working of this logical AND. See, the working is very simple. True and true is true. True false is false. False true is false. False false is false. Now over here, how the Java compiler will behave? The Java compiler will first check the value of A greater than B. If A greater than B is false, then obviously the entire expression is false. So now what the Java compiler will do is, the Java compiler will not check, it will not evaluate x greater than y. Why? The reason is very simple. If A greater than B is false, then obviously this entire expression is false. So that is why we call it short circuit operator. That means the operation is cut short in between. Something like that happens with logical OR also. Let's say I write the same thing, almost same thing over here also. That means I write A greater than B, but over here I write logical OR. Okay. Okay. So I'm sure you know how logical OR works. Okay. Over here, what will happen is the Java compiler will first check whether A greater than B is true or false. If A greater than B is true, then it will not check, it will not evaluate the second condition x greater than y. The reason is simple. If the first condition is true and if you are using logical OR, that means the entire expression is true. So again, this is also called short circuit operator. Now what you can do is, in Java, you can use these operators also. Look at this properly, what changes I'm doing over here. Instead of putting double ampersand, I can put single ampersand. Instead of putting double vertical bar, I can put a single vertical bar. If I put a single ampersand, then this is also logical AND, but this is not short circuit. So now what will happen is, even if A greater than B is false, the Java compiler will still check whether this second condition is true or false. And similarly, even this is not a short circuit operator, but it will still do logical OR, although it is not short circuit. So now I have these 4 examples in front of you. Copy these 4 examples in your notebook and in your own words, just write some notes that why these are called short circuit operators, this one and this one, and how they are different from this one and this one. So pause the video and write some notes in your own words. Okay, coming back. Now we move on to another category of operator, which is called special operators. By the way, there are two special operators in Java. One is called dot operator, also called period operator, and another is called instance of operator. But the problem is that you will not understand these operators right now. So right now what you do is just copy all these things starting from special operators till this red color, okay? And then what I will do is I will teach you these special operators when we do chapter number 4, classes and objects. After copying all this, also give one heading, and that heading is mathematical methods. So pause the video, copy this much. Okay. So now let's start with the topic of mathematical methods. Okay, listen. Now, see what happens is Java has many predefined classes. And you should take this word many very seriously. Java has many predefined classes, and those predefined classes has many methods in them. So in Java, there is a predefined class called math. Math is a predefined class. And class math has many methods which do some kind of mathematical work. Okay. So for example, take this one, SQRT. I'm sure you remember the SQRT which you had studied in C language. It will give you the square root. So in Java also you have a method called SQRT which will give you the square root of a number. Now, if you want to use SQRT in Java, you will write something like this. Y is equal to math.sqrtx. So math is the name of the class and SQRT is the name of the method. So how do you read this? You read it this way. SQRT of math, that way. So if x is equal to 49, y will be equal to 7. Now, look at your printed notes, and in your printed notes, you will see this table, page number 13 or 14, you will see this table. Okay, you can pause the video and you can look at this table. Okay, I hope the table is there in front of you. So now this is the table which gives you all the mathematical methods. Okay, now there are many methods over here, sine, cos, tan, and all these things. All these methods I am not going to explain you, because if you read the description you will understand them very easily. What I will do is I'll explain you 4 methods, and that are these 4 methods, these 4. So the first method is called ceil. Ceil stands for ceiling. Second, floor. Then this is called rint. I repeat, rint. And this is called round. Okay. So let's understand how these methods work. Now what I will do is I will dictate the description of the method, and you should write the description over here. Look where the mouse pointer is moving. You should write the description over here, and write in little smaller handwriting because you need to write some examples also over here. Okay. So start writing the description. I'll dictate. Come on, write. It returns the smallest integer greater than or equal to its argument, but as a real number. I repeat, it returns the smallest integer greater than or equal to its argument, but as a real number. Okay, now in order to understand this, let's take one example. Let's say I write something like this, math.ceil of 7.65. Now over here 7.65 is the argument of seal. So ask yourself one question, which all integers are greater than or equal to 7.65? So the answer is 8, 9, 10, 11, all these are greater than or equal to 7.65. Of all these integers, the smallest integer is 8. So 8 is the answer over here. But do one thing, look at the last few words of the notes which you wrote just now. So the last few words are telling you, but as a real number. So what will happen is, although the answer is 8, it will be given in the format of a real number, 8.0. Okay? So quickly pause the video and copy this example over there. Okay. Now we move on to the next thing, and that is floor. Now write the description of floor over here. Come on, write. It returns the largest integer lesser than or equal to its argument, but as a real number. Okay. So let's say I have math.floor 7.65. Come on, quickly. Now think, which all integers are lesser than or equal to 7.65? So it is 7, 6, 5, 4. Of all these integers, which is the largest one? It is 7. But as a real number, so it will be 7.0. Let me see whether you understood seal or and floor. Let's say I write math.seal 6.1. Math.seal 6.1. What will be the answer? The answer will be 7.0. Let's say I write math.floor 6.1. Math.floor 6.1. What will be the answer? The answer will be 6.0. Okay? Alright. Now let's move on to REnd. Come on. Write its description. Very simple. Right. It performs rounding of its argument to the nearest integer and returns it as a real number. Okay, what we'll do is, we will write a definition of round also. Okay, right. Now I'm dictating definition of round. It performs rounding of its argument to the nearest integer and returns it. That's it, full stop. Now let's understand what is REnd, what is round. Very simple. Now REnd and round, both of them will basically perform rounding the same way which we do in the real world. So when we round 7.5, we get 8, but REnd will give it in the format of a real number, so the answer will be 8.0. Now the next function is round. Round will do exactly the same thing as REnd, but it will not give the answer in the format of a real number, so the answer will be 8. Come on, can you tell me what the answer of this will be? It performs rounding, so it will be 7.0, and this will be 7. Okay, now what I suggest is you pause the video and you copy the 4 examples in your printed notes starting from here. Pause the video and do that. Okay, so I think you have already done that. Now, before we go to the next topic, I just want to show you something in operators. So in your printed notes, I think on page 12 or 13, you will see this table. Okay, look at this table. Now, this table is giving you all the operators which are available in Java. I'll just tell you one thing about this table. In this table, all the operators are listed in the order of their precedence. So the operator which has a higher precedence will always be seen above the operator which has a lower precedence. For example, look, you see this multiplication over here and you see this plus over here, which means that multiplication has a higher precedence than plus. So if you have a statement like this, a plus b into c, I repeat, a plus b into c, then b into c will be performed first because it has a higher precedence. Okay. Now in the last column, this heading which you see over here, this heading is called Associativity. I repeat, it is Associativity. Now over here you will see the associativity is either left to right or sometimes it is right to left. So what is the meaning of left to right and right to left? By the way, this is division operator, division, and division has what associativity? Yeah, it is left to right. So now what is the meaning of this left to right? So look over here. Let's say I write a statement like this. I write A divide by B divide by C. Now there are two division operators over here and the associativity is left to right. So what will happen over here is that A divided by B will be done first and then B divided by C will be done. Okay? Alright, so this is the meaning of left to right associativity. Okay. So that was operators for you.